Hey guys, for topic 1.14, it is a calculator heavy topic, so we're going to need to be able to navigate your TI calculator. What we're going to want to do here is make sure that we have the idea of modeling, which is also sometimes called creating regressions, and be able to apply those regressions or models to the different types of functions that we have studied so far. So we're going to jump right into it. If you notice, the front of your page of your notes has this information on it, and I'm kind of hiding it over here, but the back of your page has the steps to build a regression model on the graphing calculator. So the steps that I'm going to do on my screen, on my calculator, are here on the back of your notes. Okay, so it's there for you. Now, we're just going to jump right into it because really seeing examples here is what's going to help us out. This question in example 1 says, the age in weeks and weight in kilograms of 5 randomly selected babies from a particular pediatrician's office are listed in the table above. A linear regression, we highlight, y equal to a plus bx, can be used to model these data. 99% of the time, the question is going to tell you what kind of regression you're writing. In this case, a linear regression in the form a plus bx. The first thing we're going to do is write the equation of the linear model for these data, where the output is the predicted weight and the input is the weeks. So what we're going to want to do, following the steps written here, is we're going to turn the stat diagnostics in our mode menu on. So we go to mode, and we're going to scroll down to where it says stat diagnostics. So for me, that's on the screen, and I think for most of us we can see it. We're going to go to on and click enter so that it's highlighted on. To get out of the mode menu, we want to quit. So we press second mode and it goes back to the regular screen. I'm following these steps here now. What I'm going to do is I'm going to go to stat and use the option 1 for enter to be able to edit a table. I'm going to put this entire table in where L1 is my input values, 1, 5, 6, 8, and 12. And L2 is my output values, 4.2, 4.4, 4.8, 5.1, and 5.7. Double check for typos, we look good. Now, after I type in that table, what I'm going to do is I'm going to go to the stat menu, so stat and then over to the calculate menu, and I'm going to choose the regression that we are using in this option. Now, it says it even on here, there are 2 linear options, ax plus b and a plus bx. If we just check the form that we want, a plus bx, we see that we're actually going to use option 8 here. I'm writing that on my notes, that we're using option 8 for linear regression in the form, literally we'll say it on there, option 8, a plus bx. So I'm going to scroll down to option 8 or choose the number 8, and I'm going to use this screen to write my regression. Now it is vitally important that when you are doing this step, you go down and on where it says store regression equation, you are going to put a y1 there. That is so huge for us, okay? Put a y1 there. And we put a y1 there by pressing alpha trace enter. So we press alpha, traces up at the top, and then enter. It's a shortcut to put a y1 there. And what we're telling the calculator is that when it calculates the linear regression from this data, I want it to already type it into y1 for me. We then press calculate, and it's going to give me the information for this particular regression. Now, if we're writing the equation like it asks in example 1, we're just going to take the values a and b and we're going to plug them into the equation, which means we would write y equals to 3.545 plus the b term, which is 0.185 times x. I follow the exact pattern we have here in the equation with the numbers I get out for a and b. Now, this next question says, what is the predicted weight output of a baby that is 10 weeks old? They've given me an input value. So what they're asking me to find is W of 10. Instead of writing W of 10 though, because my calculator has stored this regression equation in an equation called y1, we're going to instead write on our paper y1 of 10. Because what I want to do on the home screen of the calculator is press y1 parentheses 10. So to get the y1, we go alpha, trace, enter, parentheses 10. Notice, it's exactly what I wrote in my calculator and on my paper. Once I press enter on my calculator, it's going to show me the predicted value if I had just taken that equation and evaluated that function at 10. Let me go get rid of that parentheses. We get the same value. And this doesn't seem like it saved us much time, but when our equations are much more complicated than what we just did with this linear equation, we're going to want to let the calculator predict our values for us. And we predicted that the weight is going to be 5.395 kilograms. Part C says the weight of a sixth baby is 5.3 kilograms. Using our linear model, what is the age of this baby? Well, it's told me that the output is equal to 5.3, which means I'm trying to see when this graph that we already have would be equal to 5.3. So if I use that output as an entire new equation, when I graph this function, we're going to see two lines that cross here at this particular point. We want their intersection, which means we are going to use, sorry, I don't know why I moved that over. We are going to use this intersection point by going second, trace, 5, and then move the turtle towards the intersection point. By turtle, I mean this little thing. It looks like a turtle to me. We're going to move the turtle towards the intersection point. Just get it pretty close and press enter 3 times. Enter, enter, enter. When it gets to the point that says intersection, it's telling me when the output is 5.3, the intersection point, or the t value, x value here, is going to be t equal to 9.48648, which we're going to round to 9.4865. As a note for me, anytime you're rounding, you're keeping 4 decimals every time. 4 decimals. Okay, like I said, these are just calculator skills. If you've gotten lost in the calculator skills already, I want you to pause this video and go back and try this again. We need to be able to, 1, write the regression in the calculator, 2, predict the future with an input value, and given an output value, find the input value. So go back, try all these 3 again if I lost you at any point during this process. Okay, the next 2 examples, if you're ready to move on, it says the table provides data for 7 ordered pairs, and using a logarithmic regression, again, we're looking for the type of regression here, construct a natural logarithmic model for a function y, for model f for y as a function of x. Write an expression for f of x in the form f of x equal to a plus b times natural log of x, where a and b are constant. Then use the model to predict y when x is equal to 5. Now, we've got a lot of stuff happening in our calculator that we want to clear out. To clear the calculator in general, you will press second plus 7, 1, 2. We get this RAM cleared screen and we're good to go. If we wanted to start from the beginning, we go to mode and we turn our stat diagnostics on, because every time you reset your calculator, those stat diagnostics turn off. We go to stat, we go to edit, and we're going to type in that entire table. All of the input values go on the L1, all of the output values go on the L2. Make sure you take your time here so that you don't have any typos and you get all of the points correct. So I have my input values, Then I go back and I have my output values. We give a quick check for typos. We look okay. Then we go to stat and calculate. Now here's where we have to make a choice. Remember, this one was called a logarithmic regression. A logarithmic regression is a natural logarithm regression. So we're going to use option 9. You either scroll to number 9 or you click option 9. On the store regression equation line, we want to put y1 so that the calculator will graph the function for us. We go to alpha, trace, enter to make that happen, and then calculate. It's giving me the a and the b value plus r squared and r, which will eventually become something you know about, but the a and the b value will go here, boom, a, and here, boom, b. So when we fill in this formula on our notes, if we're writing this function f of x, it would be f of x equal to a, which is 2.8636, 4 decimals, plus b, which is 1.8185 times the natural logarithm of x. If we're using the model to predict the output when x is 5, that means we're trying to figure out what f of 5 is. But instead of typing f of 5 on my calculator, I'm going to pretend like this is y1, since y1 is where I have this really accurate graph written on my calculator. Look at all those decimals it saved for us. So we go alpha, trace, enter, and we put the number 5 in there. And then boom, it's going to calculate for me the value at f of 5, which is 5.7903. Oh, I covered up the 3 with my calculator, sorry. 7903. We repeat. I'm going to clear my calculator to do the next example. Once I cleared it, I do have to go turn the stat diagnostics on. And I'm back to normal. I'm going to go to stat, I'm going to go to edit. I'm going to start typing in all of these coordinate points. And then the outputs. And once I get all of that in there and I check my typos, this is so much clicking. We realize that this question does not tell us the type of function that we have. Interesting. So what we're going to want to do is we're actually going to want to see what this graph looks like. If we just press graph right now, nothing's going to show up. But when we go to y1, we can go up to the plot and turn on plot number 1. Plot number 1 is going to plot L1 versus L2 and graph your little dots. Look, there's our coordinate points. Now, of course, this looks like nothing. I should have 1, 2, 3, 4, 5, 6, 7, 8 coordinate points on my screen, and I only have 2. On Desmos, if you were doing this, you'd just like pinch and zoom however you wanted. However, to zoom appropriately for our data, that is statistics, we press the zoom button and then option 9, which is zoom stat. Look at this graph. We see that it goes up and it comes down. What kind of function goes up and comes down? This is going to be a quadratic function. So when we go to do the actual regression on stat calculate, we're going to choose the quadratic option, option 5. We store the regression equation in y1, alpha trace enter, and we calculate. We have the a, b, and the c that create this quadratic equation. We put them exactly where they belong, which means that this would become the equation y equal to negative 4.8832x squared plus 15.9580x plus 4.9956. That is a very, very accurate coordinates, coefficients for this quadratic function. We chose it was quadratic because of the way that the graph looks when we statistics it, using statistics. Then we're going to use this model to predict the output when the input is 2.5. So like I'm saying, we're doing y1 of 2.5 back on the home screen so that we can plug that value in. So we will quit. Alpha trace enter 2.5. We have our output prediction 14.37. That's going to round to 10. That's not going to round to 10. I'm crazy. 3709. My bad. I don't know what I'm doing. The point of this lesson, topics 1.14, is to make sure we know how to use the calculator to write regressions for different data models. We also want to be able to use that regression to predict the future when you're given an input and find the input when given an output. This is a very calculator-heavy day, and your homework for today, your CYU, is going to have you work on these kinds of questions, so you're going to want to use class time to work on that CYU.